The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So the first thing we're going to do is a power module, and it's important that when you're trying to draw power from any source, even a battery or anything like that, that you try to match, or you want to draw the maximum amount of power, you need to have the right load on it. So we're going to try to figure out experimentally what the right load is for this solar panel. And the way you do that is you hook up a resistor or a potentiometer to in a closed circuit around this, or first you measure the resistance of it, then you hook this up in a closed circuit and measure the voltage drop across it, and you can calculate power from V squared over R. And so you just do that for a bunch of different resistances, just changing this, and you should be able to get a graph that goes up and then down, and if you graph power versus resistance, and based off of that you can figure out what the appropriate load to place on it is, and so you'll generate a power curve for that. Again, make sure you don't measure the resistance when it's hooked up, because you're going to fry the voltmeter. And then the second thing we're going to have you do is optimize the angle. So you want to put the solar panel at different angles, both in this direction and in this direction, and measure for a variety of angles what the power output it is. And so for that you can just choose a resistance with the potentiometer and then measure voltage and get power that way. And then I have protractor somewhere. Yeah, or what?
Yeah.
Close enough, yeah. And so you can use that to measure the angle of the solar panel. And when you're doing this, I want you to take, for the angle ones and the shading ones, I want you to take at least 10 data points. And for the voltage one, I want you to take at least 15 data points for different resistances and powers. And then the last thing we're going to look at is how shading the solar panel affects the energy being outputted by it. And in this case, I want you to, if you look at these solar panels, each of these long things is an individual cell, and they're wired in series. So I want you to shade the solar panel going down this way and then going across this way, and just measure the surface area of the exposed solar panel. And then for that one, just choose the angle that you like and choose a resistance that you like, and then measure power being outputted by that. And as you can see, it's kind of annoying to attach wires to other wires in the developing world, especially if you don't have soldering techniques or anything like that easily available. So there are a lot of different ways of attaching them together. A lot of times the way you'll see people wire things is just taking two wires and twisting them together. And I mean, it works as a short-term solution, but you'll see entire systems rigged up that way. And yeah, it's not particularly good. So are you all comfortable calculating power given this? Will you just do V squared over R?
19.5.
We're not.
Yeah,
we're not going.
7. Yeah.
We're not going to use this.
Goes up to 500. So go up to 20. Go up by 20.
58. Yeah, it's gone up to 20 now. 20.5.
That big solar panel outputs 15 watts. And most of the tiny resistors you see are rated for a quarter watt or a half watt. So if you hook them up to this, they would just burn out. They would get super hot and burn out. So this one's rated for, I think 0.3 or 0.4 amps. Yeah, and so change your angle relative to pointing to the sun, if that makes sense.
You mean like, yeah, so it should be
So if like the
similar.
sun is there, then like kind of
No, it's just
tilt your panel here and then angle towards the sun, like kind of like that. Does that
Okay.
make sense?
Uh,
Like the sun is there.
about a couple of hours.
That was the wrong side to pull it out.
You might want to
Mine's
move the
like-
battery out of the way too, because I think it might be shading. a bit soon.
Battery. We're gonna use it
Kind of
for
run.
any moment really quick.
Makes sense.
Ready?
Yeah, I'm good. Okay. 20.5.
Wait, didn't you move it?
The ring is changed.
72.
Okay.
So now,
And so now we flip it 90 degrees and then do the exact same thing.
Yeah, that's what I was trying to figure out. If they're gonna go metric. Let's say it's 95. That's shade. How much you want shade?
This lab is just for fun, so I gave people the option of either making something cool if you're feeling creative, or just doing each operation with no intent other than learning the operation. If you're not feeling creative, it's up to you. So some people made really cool stuff and some people just had fun, and anything is fine today. So we're gonna go through a bunch of things. So one is drilling holes in sheet metal. Then you'll also want to cut PVC pipe, and if you could cut this on the bandsaw, but it's probably going to be a little uneven. And this is actually faster and really successful. So what you do with this PVC cutter is you just open it all the way up, and then you just keep on ratcheting. Really quickly cut a ring. Very handy. You couldn't use that tool on metal, unfortunately. So we have this tool for cutting pipe. This is the sharp bit, and these are just bearings that allow the pipe to spin around and around. So what you do is you open it up, you load the copper in, you tighten it, and then you spin it around a few times, tighten it, spin, tighten, spin. The more times you tighten and spin, then the cleaner edge you'll get. If you really just use a lot of force. Force it, it'll work, but it'll be ugly. So this is copper, which is expensive, and we don't have that much. So this is the one area where you need to just cut a little ring. Don't cut half for yourself. We also are going to cut rebar. So the hacksaw is right here. For cutting rebar, well, you could just hold the rebar in one hand and use the hacksaw in the other. It's going to be really miserable and near impossible to do successfully. So we have a vise, so you can load the rebar in and then cut. And then when sparks fly, give it a half a second and then let go. Yep. So you held it too long, and you can tell by the diameter.
Maybe if it was a bigger pipe, it would be easier.
That helps because the radius is smaller.